Hello class, welcome to Geometry Lesson 4-5, which is all about congruence in right triangles. By the end of this lesson, you should be able to identify congruent right triangles. So we are going to add a theorem to what we have already talked about in Chapter 4, and this new theorem only applies to right triangles, and it's called the Hypotenuse Leg, or you can abbreviate it HL, theorem. And what this theorem means is if I have two right triangles, so if you look over at the picture, we have two right triangles, and we have a congruent hypotenuse, which we do, and one congruent leg. It doesn't matter which leg as long as you have at least one leg that's congruent to that same leg on the other triangle. As long as you have this criteria, so right angle, congruent hypotenuse, and congruent leg, those two triangles are congruent. That's called the HL theorem, or the hypotenuse leg theorem. So if we look at this, if we want to use the hypotenuse leg theorem, we have these two triangles. We have triangle LMN with a hypotenuse of 9, and we have triangle PQR with a leg of 5. I want to know, what other information is needed in order to apply that HL theorem? Well, I need congruent hypotenuses, so here I have a hypotenuse of 9, so that means I need this hypotenuse over here to also be 9. And remember, the hypotenuse is always the side that does not touch the right angle, okay? So in order for this HL theorem to work, I need to know that segment P, not Q, PR equals 9. But that won't be enough because I also need a leg, and I know that QR is 5, so that means I need MN to also be 5. So that is the additional information I would need in order to apply the hypotenuse leg theorem. All right, let's look at example 2. We want to prove that the triangles are congruent. So I'm going to walk you through a proof that might seem a little complex, okay? So we're going to start with our two columns. So remember our statements and our reasons. The first thing I'm going to write down is the given information. My given information is that segment JL is perpendicular to segment KM, and segment JK is congruent to segment LK. So that's 2 bits of information. I'm going to work with that very first piece of information first. So if segment KL is perpendicular to KM, then I can say that angle JNK has to be a right angle, just like L and K also needs to be a right angle. The reason I can say that they are right angles is by definition of perpendicular. So now that I know that they're both right angles, I can say that they have to also be congruent to each other. The reason I can say that those two angles are congruent is because all right angles are congruent. So now that I have those two right angles, and I already know that we have two hypotenuses that are congruent. We stated that back in the given, so there's our given information being used. If I want to use the hypotenuse leg theorem to prove that we have two congruent triangles, I need one more leg. And if I look, both of those smaller triangles share that side. So I can say that segment KN is congruent to segment KN by the reflexive property. But if I look at this, I now have enough information to say those two triangles are congruent. So I'm going to say that triangle JKN is congruent to triangle LKN. And I know that because of the hypotenuse leg theorem. So I've said that two triangles are congruent to each other, which if I look back at my proof statement, that's what I was trying to do, except I didn't prove the correct triangles. I proved the two smaller triangles, and I want triangle JKM. So I want triangle JKM to be congruent to triangle LKM. If I think about it, I still have those two congruent sides. And if I also look at this, these triangles also share a side. They share side KM. So I can say that segment KM is congruent to segment KM. Now that I've said segment KM is congruent to segment KM, I have two sides that are congruent, and now I need to either prove a third side or I need to find an angle. And if I'm looking for an angle, it has to be the one between the two sides that I know. So that would mean I need to know that those two angles are congruent. And this is where it's really important that we actually proved that triangle JKN is congruent to triangle LKN. Because if those two triangles are congruent, that tells us that those angles that I just drew marks on also have to be congruent. So I can say angle JKN is congruent to angle LKN. And that's by our corresponding parts. Okay, so those two angles are corresponding. They match each other on two different triangles. Corresponding parts of congruent triangles, which we knew we had, are congruent. So now that I know that those two angles are congruent, I have my side angle side, and I can say that the two bigger triangles are also congruent. So triangle JKM is congruent to triangle LKM. And now I am finished with that proof. Okay, so these are the main theorems that you've learned so far. You will want to make sure that you have these all memorized. And if you have any questions, as always, please feel free to reach out for some help. Have a great day.